So here the question was saying, let the matrix M be equal to 3, 1, negative 3, 1, 2p, 1, 0, and 2 and p. Then they are telling us to find the values of p for which M is a singular matrix. So remember what I said yesterday. I said a singular matrix is a matrix which has the determinant which is equal to 0. So in short, we're going to find the determinant of this matrix, and then we equate it to 0, then find the values of p. So we start. All right. So to find the determinant of this, we'll use what are called minors. So the determinant of M. So since M is singular, simply means that the determinant of M is equal to 0. So this same 0 is the one that will be equal to what we're going to find here. So to find the determinant of this, so first I'm going to cross out this line. And remember what I said, it is more convenient, or it really helps when you choose a line which has a lot of zeros when finding the determinant. It's very helpful. Yeah. So myself, I would like to get this one. I'm going to use this line for finding the determinant. So what I'm going to do is I'll start first by finding the minor for this 0. So meaning I'm deleting this row, and I will also delete this column here. So after deleting this, I know to say when I multiply this 0 times everything this side, the minor, when I multiply this 0 times each minor here, I'll still get a 0. So instead of me even multiplying that, I'll just write a 0 there. That's the reason why it's good to get a line which has a lot of zeros. And then you say minus 2, and then open brackets. So what I'll do again here is I'm going to delete the column where 2 is and the row where this 2 is. So meaning the remaining numbers are the ones that I'm going to use to find the minor. So this is going to be 3 times 1 will give me 3. And then minus 1 times negative 3, I'm getting negative 3, like that. So this is what I'm going to have. And then from there, I'll move on to the last part now. So in the last part, I'm going to delete this row. Let me just mute everyone. Yeah, so on the last part, I'm going to say plus P. Then this P, I'll open the bracket and say now, I'm going to delete this column where P is and the row where P is. The remaining numbers are the ones that I will use to find the minor. So here I'm going to have 3 times P. This will give me 6P. And then I'll also have a minus there. 1 times 1, I'm going to get 1. Yeah, so now here is just a matter of simplifying the expression. So this is going to be negative 2 there, and then open brackets. So this minus negative 3, we're going to get 6. And then P times 6P, we'll get 6P squared. We'll get 6P squared. Then P times negative 1 there, we'll get negative P. And then this, we're saying this is the determinant, and then since the matrix is singular, we're equating this to 0. So this negative 2 times 6, we're getting negative 12. So what I'm having is 6p squared, then minus p minus 12, which gives us 0. So here what we do is we find two numbers that when we multiply them, they'll give us negative 6 times 12, which is, I think, 72. Yeah, negative 72. And then when you add them, they are going to give you negative 1. So these numbers, I think these numbers are 8 and 9. Yeah. When you add them, they'll give you negative 1, and then when you multiply them, they'll give you negative 72. So these numbers are 8 and 9. So this is going to be 6p. All right, 6p squared here. And then here we're saying we're going to have positive 8p, and then negative 9p. And then we write a minus there, then 12 is equal to 0. So here we factorize, we're going to have what is common there is 2p, and then you open brackets, 2p into 6p squared is 3p, 2p into 8p, you have your positive 4 there, then close like that. The common there is going to be negative 3. When you divide negative 3 into 9p into negative 9p, you get 3p. Then negative 3 into negative 12, you get positive 4. Yeah, so this will be equated to 0. Then apart from this, yeah, so from this now we do what? We now simplify, we now factorize the same expression there. So the common there is 3p plus 4. The good part with these quadratic equations, when you find that what's in the brackets, the things that are in the brackets are different, just know that you've made a mistake somewhere and you need to revisit your solution. So 2p minus 3. This is going to be equal to 0. And then what we do here, we now equate 3p plus 4 to 0. 3p plus 4, we equate it to 0. And you also equate 2p minus 3 to 0. So when you equate these to 0, you're going to have your p here being equal to negative 4 over 3. And then your p here will be equal to positive 3 over 2. So these are the values of p that we were asked to find. So when you replace these values of p where there's p in this matrix, you discover that the answer that you're going to get is going to be 0 when you find the determinant. So I think we can proceed. So here the question is saying solve the equation. So before I even move to b, you can see that this I and the first one and this one, they are just the same. Here it's just that we've been given t instead of p, but otherwise the way you solve them is just the same. On the cancelling part, there is one who's saying he's behind on the cancelling part. Which part exactly are you talking about? Oh yeah, I think I know where I know what you're talking about. You mean on what? On deleting the columns and the rows. Is that what you mean?
Yes.
All right.
Yes.
Okay. Let's see first what I'm going to do. Okay. Let's see what we can do to help our friend. So here, what I was saying was, when you are finding the minor for 0, you write your 0 there. When you are finding the minor for this 0, you write your 0 there. And then you cancel or you delete this column where the 0 is. You also delete the row where the 0 is. And then you find the minor for this. So the minor for this is just the determinant. So this is going to be 2p times -3, and then minus 1 times 1. So it's going to be 2p minus -3 minus 1. But the reason why I just wrote 0 here is because when I multiply this 0 with 2p minus negative, with whatever, with anything that I'm going to, what I'm going to get, I'll still get a 0. So I just decided to write a 0 here. So the same applies to the second part here. So here on the second part, when I write -2, when you follow this matrix of cofactors, the one I showed you yesterday, this one, which is positive, negative, positive, negative, positive, negative, and then positive, then you have negative and then positive. When you follow this, you discover that these two, where this two is, there's a negative. The position of these two, there's a negative. That's the reason why I had to put a minus in front of 2. And then I wrote the 2 there. So now, when canceling this, meaning you're going to cancel the column where this 2 is and the row where this 2 is. So meaning the remaining things are the ones that you use now to find the minor. The remaining numbers, you use them to find the minor. So these numbers are 3, 1, -3, and 1. So to find the minor, you say 3 times 1, you get this +3 here. And then you say 1 times -3, you get the -3 in brackets there. Is it clear? So this also
Yes.
applies, all right. This also applies to the last part here. All right, since you've understood, I think you can proceed. So now the next question here is saying, solve this equation, m. M multiplied by that is equal to this. In the case where P is equal to 2, and determine what? I think he said something was, yeah. I think it was supposed to be and determine the, is it and the determinant, maybe. Yeah, maybe that's how it was supposed to be. I'm saying solve this equation in the case where P is equal to 2 and the determinant, maybe. Yeah. So either way, we can solve it the way it is. So we start, we are saying this m, we write our m there. Our m is 3, 1, -3, 1, and then they are saying where there's p, we're going to be putting 2. So 2 times 2, I'm getting 4. And then I have a 1 there. Here they said where there's p, I put 2. And then there's 2 there, there's a 0 there. So this is what I'm going to have. Okay. So we're going to have our x, y, and then z there. Then we're going to also have negative 7 over 2. You have 11 over 2. And then you have your 5 here. So here, if you don't want to waste time, you know the expression for the determinant of this matrix we found was, if you remember very well, it was 6p squared, then minus p. Instead of you maybe to start finding the determinant for this, instead of you going back to finding the determinant of this, you can just use this expression to find its determinant. So it's going to be like this. So this is the determinant of the matrix M. So we equated it to 0 at first because they told us to say this matrix M was singular in the first question. But in this case, it's not singular. So this is the expression that we found. So we can use the same expression to find its determinant when P is equal to 2. So when P is equal to 2, so meaning while there is P there, you just replace with 2. So it's going to be 2 squared there to be 4. And then 4 times 6, you get 24. And then minus, you put 2 there while there's P, then minus 12. So here the determinant that you're going to get will be 24 minus 12, you get 12. 12 minus 2, you get 10. So your determinant is going to be 10. So since we are using Cramer's rule to find the value of x, y, and z, yeah, actually this question is good because once you know how to use Cramer's rule here, to mean that on those questions where we're requested to use Cramer's rule, we'll not solve a lot of questions. So you first find the determinant. When using Cramer's rule, you first find the determinant of the given matrix. So this is the determinant that we have found now. So the determinant of this given matrix now, I'll write it as D. I'll write it as D is equal to 10. So we found D, and according to Cramer's rule, you know to say when you're finding the value of x, you say you find the determinant when the determinant of D in the x, and then over D. When you're finding y, you find the determinant dy over the same d. Same applies to the situation where you're finding z. When you're finding z, you also find the determinant in z, and then divide by d. So this is how you use Cramer's rule to solve the systems of equations. So since we now know the expressions for Cramer's rule, which are these here, and then we know from these expressions that we've already found D, which is here, which is 10. So what we just need to find is dx, dy, and dz. So how do you do that? So to find dx, you are going to get the solutions here, and you are going to get these answers here. You replace them in the x column. So the x column is this. This is the y column, and then this is the z column. So you are going to get the solutions, you replace them in the x column, and then find the determinant. So here we go. You can start now. So I'll replace my solutions there. I have my negative 7 over 2. And then you have 11 over 2. Then you have 5 there. Then apart from that, 1, 4, 2. you write the remaining numbers the way they are. So now we find the determinant dx. So dx will now be equal to, so first thing, you remember what we said when you're finding, when you pick this one here, which is -7/2. Yeah. Okay, I think let me pick this one with numbers down here. It's easier for me to use it because it has numbers. If I pick the one with a fraction, maybe it might be complicated to begin to deal with fractions. So I'll pick this one. So I'll put my 5 there. So if I put my 5, I'll open brackets. So the minor for 5 is going to be found by deleting this column where 5 is, and I'll also delete the row where 5 is. So the remaining things are the ones that I'm going to use to find the minor. So I'm going to have 1 times 1 there. It will be 1 minus 4 times -3. I'm going to have -12. So this is what I'm going to have. So having done that, we can also find the minor for these two here. So I'll put my -2 there, then open brackets. I'll delete this and I'll also delete that. So meaning I'm going to have 7/2, -7/2 times 1. I'll still have -7/2. Then minus 11/2 times -3. So meaning that will give me -33/2. -33/2. And then having done that, I'll move on to the last number there, which is 2 again. So I'm going to delete that. I'll also delete that. So I'm going to have +2 this side. And then open brackets. So that will be 4 times -7/2. I'm going to get -14. And then 11/2 times 1, I'm going to get, so -11/2 like that. This is what I'm going to have. Then after simplifying this, I'm going to have, so this is 1 plus 12 to be 13, and then 13 times 5, I'm getting 65. So this will give me 65, and then minus, so this 2 times what's there, so this will be -7 plus 33. So you have your -7 plus 33 being equal to 26, and then 26 divided by 2, you find your answer to be 13. 13 again times 2, you still get 26. So this 26 is going to be a positive. Sorry, let me check. No, it's going to be a negative. So minus 26. Yeah, it's going to be a negative 26. And then, so we move on this side. We're going to have -11/2. And then -11/2, you are subtracting it with 14. You get your answer to be 39/2. 39/2 times 2, you still get your answer to be, you just get your answer to be 39. So that will be a -39. Then here to find the determinant now, you just have to add them. So you just have to add them. So you have your 65 minus 26, then minus 39. Then you're finding your value of x, your dx to be 0. When you add this, they are giving you 0. So meaning on this expression there, you can replace where there's dx with 0. So we're going to have this, which is going to be 0 over 10. So meaning our value of x, which we found, is going to be 0, like that. So we can move on. We find dy. So at least we found the x. Let us now find dy. Let me just delete this. So this is how it's going to be. So to find dy, we're going to put our answers, our solutions in the y column. Let me just delete all this. Okay. All right. So let us find dy. So to find dy, we're going to put our solutions now in this column, which is going to be negative 7 over 2. And then we have 11 over 2 there. And then we have a 5 down there. And then in this first column there, you have your 3, 1, 0. You write them like that. So to find dy again, I'm going to use the last row here as well. So the first one here, remember what I said, you pick a row which has a lot of zeros, and I've discovered that the last row here has a 0. So meaning the first, when I find the minor for this 0, I'm going to get a 0 like that. So I'll just put a 0 there on the first minor. And then the second one there, I'll put my negative 5. And then open brackets. Here I'm going to delete this. I'll also delete that. The remaining one will be 3 times 1 will be 3. And then minus 1 times negative 3 to be negative 3. So it will be plus 3. And then we move on. I delete this one for 2 there, and then that one. So I'm going to have a positive 2, then open brackets. So this is going to be 3 times 11 over 2. It's going to be 33 over 2. 33 over 2, and then minus 1 times negative 7 over 2, it will be, so since that 7 is negative, so here to be positive 7 over 2. So when you add this, you are going to get this 3 plus 3, you get 6 times 5, you get negative 30. And then here you're going to have 33 plus 7, you get 40. Just remaining with 10 minutes. Okay, let me just finish up this one. So this will be 40 divided by 2, it will be 20. 20 times 2 to be 40 again. Oh, sorry, 20 times 2, yeah, to be 40. So I'm going to get 40. So when you add this, you're going to get negative. You're going to get a positive 10, sorry. This is going to be 40. So you're going to get a positive 10. So here you're going to put a 10 there. Then divide by your d there, you know it to be 10. So meaning your answer will be 1. So you do the same to dz. You can replace you can put your solutions in the z column there, and then find the value of d. Yeah, and then afterwards you can prove your solutions by putting them there, and then you multiply them. You see if you're going to get this. Let's quickly move. So if you want the solution for this question, you can check on the link below here, which I've put. Yeah, I solved all of them together with the last one here. So you can check from that link. So, yeah, let's see. Oh, so this is the Cramer's rule that I was talking about on applications for determinant. And we have seen what I was doing. It's just a matter of replacing your solutions there, B1 and B2, you put them in the X column there to find the X. And then you also find the determinant, D, for the whole matrix, the given matrix. We move on. So same applies to these questions. I think you guys said you're going to be having a lesson at 11. So I don't want to enter into your time. You need also to start preparing for that. So these all questions here, you are requested to use Cramer's rule. So what I'll do is I'm going to answer some of these questions and then I'll put the link down here. So when I distribute this same slide, you'll be able to check the solutions for this question using that same link. Yeah. So I'm going to solve them. Yeah, I'll put the link there. Let me just go through. I just want to see which one. Okay, let's look at the inverse in this last remaining 7 minutes. So if we find the inverse, you need to know what is called an adjoint. So the adjoint of a matrix is just the transpose of the matrix of cofactors of a given matrix. Yeah. So there's also this expression here. It's very important. It's the one that you use to solve question 6. So if you don't know this, you can't solve question 6. So this is the question I'm talking about. Question 6 here, there's supposed to be D. You can see that this D is nothing but the adjoint of the matrix C. So D is just the adjoint of the matrix C. So in short, this question was just asking you to find the adjoint for this matrix. And then the adjoint is just you find the matrix of cofactors of this matrix C, and then you transpose it. The transpose of this matrix of cofactors is the one that you call the adjoint. If you want to know how to solve this question here, there's this link down here. You can check through it. You can open it. You'll see the tutorial video on how I solved this question. I also explained the adjoint on this same question 6. Yeah, same applies to this. It's also just testing you to find the adjoint of a matrix. And then if you need the solution for this question, there's also this link down here. Yeah, I would have solved these questions now. I was told you're having a lecture, so I shouldn't exceed my given time. So here we're saying let A be equal to any given matrix. It is just finding the inverse of a matrix. So the inverse of a matrix, so if you have A as your matrix, then you want to find the inverse of this matrix. It's just a matter of you finding the determinant, and then you divide it into 1. So you're going to have the determinant of A, and then you say 1 divided by the determinant of A, and then you multiply it with its adjoint. So you multiply the adjoint of A with with this, and then you find your solution for the inverse of that matrix. So this is what I'm trying to talk about. You can see it's just the A inverse is just 1 over the determinant of A times the adjoint of A. So this is what I'm talking about, and I think I solved this question. I'm just going to put the link down here. You're going to see how I solved the whole question. I solved most of these questions. Actually, I solved all of them. Yeah. So I'll put the link down there, and then on your spare time you can watch and check how you find A inverse, B inverse, A times B, A B inverse, and how you verify that this is equal to that. I solved it in a tutorial video. So I'm going to put the link down there before sending the slide. All right, same applies to this. they are also testing you on the same thing. You know, the identity matrix for a 3 by 3 matrix is just this here. You put the ones in the, okay, this is how it looks. So the identity matrix for a 3 by 3 matrix. So when you multiply this by 12, it's just the same as you putting 12 where there's layer ones there. So what I've written here is just this part. Yeah, so this part is equal to, so this part here is equal to that part. And then 13 times A, meaning you're just multiplying 13 with all the numbers in this matrix A. And then A cubed means that you're multiplying this same A, you're multiplying it 3 times. So you first multiply 2 A's, and then come and multiply the final answer with another A, and you find the solution. And then they're saying, assuming that A inverse exists, show that the equation in I can be written as A inverse is equal to 1 over 12, 13I minus A squared. So I'm also going to solve this question. I'll solve it in full so that you see how to solve so that you see the solutions for this question. Then I'll put the link down here before sending the slide so that you can check and see where you may have gone wrong in solving it if you've tried it before. Yeah, this one I solved it yesterday. I'm just remaining to put the link down here. You'll see how I solved it. So here, let me just say something. If they are saying find the values of beta, what values of beta does this matrix here not have an inverse? So if they say this matrix has no inverse, means that if this matrix is A, if we say it doesn't have the inverse, it means that its determinant is equal to 0. So the adjoint can be there, but the determinant is going to be equal to 0. So if the determinant of a matrix is equal to 0, it means that that particular matrix has no inverse. It's infinite. Its inverse is undefined. That is what they are trying to talk about. Either way, I solved this question yesterday. I'm just remaining to put the link in this slide so that you can be checking how I solved it whenever you're revising on this question. So thank you very much for watching. Let's meet in the next lesson where we're going to start analytical geometry, but of course that will be after the mock. Yeah, the time is even up. The link will close very soon on its own.